live. We're live.
Okay. Alrighty. Thanks everybody for joining. We're getting started. Stuart's going to be talking to us about CJDNS today. And next month, I think we're doing the UEFI stuff. I need to double check. I think that's in the queue for next month, where we have hardware. Nina will be talking locally, and then Brian will be presenting remotely on that. I don't believe we have anything in July or on right now. So if you have any ideas or topics, please let us know. And with that, I'll turn it over to Stuart to talk about CJDNS.
Okay, 5-second shout out for this tool is called View Your Mind. It's a Linux tool for organizing your thoughts for presentations and other things. And oops. So with that, I would make it go away and start the presentation. So the first thing to look at for CJDNS is the why. And if you've ever set up a VPN with a lot of places, the more nodes you get in your VPN network, the more cumbersome the configuration gets. So this is, I'm going to go over a few of the tools for linking your different networks with IPv6. The first one is 6 and 4, and that creates a tunnel between two networks, two IP6 networks, and it's unencrypted, and it lets you link up IP6 without, whether or not your ISP supports IP6 or not. The next handy thing that everyone probably here knows about is OpenVPN. Is everyone here familiar with OpenVPN? Okay, OpenVPN is probably the most efficient way to create a point-to-point link. It's encrypted over the link. It routes IP6 or IP4 between your subnets, and you quickly get a lot of point-to-point connections. And when that gets cumbersome, the next thing you do with OpenVPN is a star configuration. You set up OpenVPN as a server, and then you can have a lot of clients that can connect into the server, and that's more convenient to configure. You've only got a config for each client and one config for the server, and the only problem is you've now got a central point of failure, and all the communications have to go through the server. So another attempt to solve this problem is a system called Tink. Does anyone here use Tink? Okay, yes. Tink is a system where you create a common configuration, and it will automatically set up lots of point-to-point links for you. So that was an older attempt to solve this problem. Now, what we're going to talk about is CJDNS. That makes it all the tremendously easy. It uses a mesh configuration. In CJDNS, each node configures immediate peers only, and there is no config at all for Ethernet peers. If there's another CJDNS node on the Ethernet, and you've got with broadcast enabled, and you join, connect to the Ethernet, boom, you're in the mesh with no configuration. Now, the CJDNS is difficult to classify as to whether it's layer 2 or layer 3. The crux of the matter is it's both. It can use its Ethernet connections are layer 2, and its UDP connections are layer 3. And it itself provides IP6 routing. So the internet is not required. You set up a CJDNS net with mesh with no internet, just with ad hoc Wi-Fi. It dynamically adapts to changes in connections. Ethernet peers are discovered automatically using Ethernet protocol FC00.
What does FC000 mean for that? Is that a proper name?
CJDNS.
FC00, okay, so.
Right, and you'll see why they picked that number. It's configured the UDP peers. When you use the internet for connectivity, because you can't get a Wi-Fi link, then you can use the UDP protocol over IP4 or IP6. And it uses random ports to make so that you can't firewall and stop CJDNS very easily, just by port. So the Wi-Fi can use ad hoc, managed, or mesh protocols. For instance, you can have, we had a talk here, it got me started on meshes. And that's where I discovered the Gathman Advanced, and I've been putting that in places. So you can run CJDNS over that. That basically makes your Wi-Fi behave like an Ethernet over an extended mesh. Or it can work directly with the ad hoc and do its own relaying, or it can use managed nodes. All that matters is you have some way of talking between the CJDNS nodes.
Is that a typo at the bottom?
No, the 902, oh, right, it is, it's 802.11s. That is a typo. So, the CJDNS is end-to-end encrypted. What that means is that it doesn't matter if relay nodes are compromised. With OpenVPN, let's say you have that star configuration, and someone has compromised the central server. Now your communications between the clients are potentially compromised because that central server has access to the unencrypted data as it reroutes between the clients. So OpenVPN is not end-to-end encrypted. It only encrypts the links. And CJDNS is end-to-end encrypted. So if compromised relays are not a problem, it uses cryptographic addresses. Now the way that works is every node has a public and private key, and the IP address is simply the hash of the public key. And by convention, addresses are constrained to be in the FC/8 IP6 subnet, which is why the FC shows up all over the place in the names. I should have mentioned that. So because each node has a public and private key, IPs are authenticated. So unlike in the conventional internet, there's no such, you can't do IP spoofing. Well, you can't with the usual cryptographic disclaimers. And there's always the potential to crack the ciphers involved. So because the IPs are not easily spoofed, the CJDNS is source routed. Now, source net routing is bad news in the conventional internet because it makes IP spoofing even easier. But since we are already preventing IP spoofing, source routing is not a problem in CJDNS. And because of the source routing, there can be experiments with routing protocols without sacrificing compatibility with the protocol. For instance, Currently, the most common routing protocol used by the current releases of CJDNS uses a distributed hash table to quickly find peers of the destination node that you want to get to. And you can then query a node as to what peers it connects to, and so that is the way that you can find a route to the node that you want to get to. People are not satisfied with some of the performance characteristics. So right now they're working on another routing algorithm that they call super nodes, where some nodes use a lot of memory and gather more information about the network, and then offer routing services to smaller nodes. And so this is the idea with this, is that you would have servers that would offer routes to smartphones that would not, spend as much memory and computation on routing. And again, because while the super nodes, if they're compromised, might be able to do a denial of service, they're not going to be able to intercept your traffic. All they're going to do is give you bogus routes if they're compromised. Okay, so CJDNS at this point is a very convenient alternative to OpenVPN stuff. When you get a lot of nodes, OpenVPN becomes cumbersome when you get beyond where a star configuration is efficient. And so CJDNS then becomes a tool to conveniently expand your corporate network without a lot of configuration. This is a more paranoid view of what CGNS is for. The end-to-end encryption means you don't have to trust any relays. Source routing means no centralized routing. With the conventional internet, routing is basically centralized, and which means that your IP can be isolated, and by the authority that runs the centralized routing. The cryptographic address allocation means there's no central IP allocation. You don't have to ask the IANA for an IP address. One that is not anonymous. This is not a substitute for Tor, because you can very easily find out who's talking to who over the CJDNS network. You just can't find out what they're saying. So what the government calls, what do they call that, where they just find out who's talking to who?
Metadata.
Metadata, right. So the metadata is available on CJDNS to see who's talking to who. And you'd have to use another layer if you need anonymity for some reason. But then, of course, you lose performance. There's also the current routing system, because it uses distributed hash tables. There is a known denial of service attack called the Sybil attack that can be used to isolate prevent a particular address from getting registered in the distributed hash table, which would make it very difficult for other nodes to route to it. And there are mitigation measures in place in CJDNS, but so because of so there's always ongoing research into improving the routing algorithms, and because of the source routing, any kind of experimental algorithm can be dropped into an implementation and be fully compatible with all the other nodes that are out there. That's the beauty of the source routing. Okay, platforms. These are the, we're just starting at the bottom: Windows, Android, FreeBSD, and OS X. I personally talked to people using the OS X implementation and the Windows implementation, and have not personally talked to anyone using the Android or FreeBSD implementations. Since we're Linux, the OpenWRT has a package, I personally made the Fedora and EPAPL packages available. And so it's just yum install, DNF install, and there's Debian packages, although I personally have not, in Ubuntu packages, there's people that do Debian and Ubuntu say that this is the best place to get packages for those. Now, this is called Be Careful Who You Peer With. Once you, when this Hyperborea is the largest CJDNS mesh, and there's join the Hyperborea network, will give you public nodes, which is a way to get started. They're nodes that just have a public password so that anyone can connect to it, and so then they have lots of peers. And so that's kind of antithetical to the be careful to who you peer with, but what the people running those nodes do is they change their passwords periodically. So your connection to the public node will probably stop working in a few months. It's just there to get you started. And then you find some friends and you set up peer connections. Or if you don't have any live friends that you can talk to face because you're living in your mom's basement, then you can get on Hatch Peering. Once you're on the network, you can get to the ircfc00.io. And there's a very interesting network map at h.fc00.org. And how are we doing on time? Do we have time to look at the network map? I think so.
We have 90 minutes.
90 minutes, okay. So I am going to show everybody what the network map looks like. Let me get rid of the Google Hangouts and pull up h.fc00.org. And move this over and make it full screen. So this just gives you an idea of all the, this is just a little JavaScript app that accesses there's a node that just goes and collects all the information that it can about various nodes out there on the Hyperborea CJDNS mesh. And the peer connections are publicly available in CJDNS. That's how the routing works. You can ask any node, who are your peers? And it'll give you the public key of all its peers. And so you can have fun making all those little maps and stuff. So private meshes. You might, for a corporate network, you might decide that you're not going to connect to Hyperborea because there's all these hackers and stuff on Hyperborea. You're only going to use CJDNS to connect your corporate offices to reduce your configuration. But you can't count on that. Just like with the conventional internet, anybody can run something like iodine, and set up a tunnel through DNS or otherwise leak your corporate network out to the world at large. So you can't count on, so anybody on that corporate network could decide to add a peer to someone in Hyperborea, at which case, boom, your corporate network is connected to Hyperborea. The same issue is with DNS tunnels and all the other things that they work so hard to try and prevent. But because IP addresses are not spoofable, IP set is your friend. Is everyone here familiar with IP set or any? Okay, let's more, if you do firewalls in Linux, IP set is a utility that lets you provide a set of IP addresses. It very efficiently stores them as a hash table in the kernel, and it can compress them by subnets and stuff like that. So you basically list and say these are the authorized CJDNS IPs to access this service, and you make an IP set for it. And so now that's actually far more secure. Just even if your corporate network is connected to Hyperborea, only those authorized IPs can access that service. And those IPs are actually authenticated at the IP level. So it's more secure than what corporate networks try to do with trying to prevent all leaks into the, in or out of their corporate network. And the other thing, the main thing you've got to watch out for once you accept the fact that it's probably inevitable that you'll eventually be connected to Hyperborea is bandwidth. It's one thing to have connectivity. It's another thing for people to be watching videos over using your node as a relay. So you'll want to monitor your peers and see what kind of bandwidth they're using, and then so you can, and since you personally talk, and then you can talk to them and say, hey, how come you're using a gigabyte a day on Hyperborea? And they'll say, I don't know, let me look at my peers. And you can see who, and you might need to restrict it. Now, what I do at home is I just, I've set up my firewall. I use traffic control in Linux. Anyone here familiar with that? Yeah, traffic control lets you limit bandwidth. Among the many things it does, it can limit bandwidth for so you can recognize the Hyperborea, since it's your personal peers, you know what ports it's going to be using, and you can say any traffic on this port. So I want to limit it all to, I limit it to 512 kilobits a second. And whatever you want to do with that, is fine by me. And sometimes it gets maxed out, but I've allocated a certain amount of bandwidth to Hyperborea. Okay, now when you have a CJDNS network, some things can be rethought. For instance, Telnet is now secure. When you telnet to a CJDNS IP, the IP is authenticated and the connection is end-to-end encrypted. It's more secure than going through OpenVPN that's relayed through a node, because it goes in the clear through the relay node. But the one thing to keep in mind is that DNS is not secure. So if you're using a name, you still have to consider that the name server could have been compromised and being returning the wrong IP. And that brings up, I forgot to put this in the slides. Why is it called CJDNS? A little historical perspective. Well, the original purpose of the project was to create a decentralized DNS, because the creator was very tired of all the security issues with DNS, and the ultimate security issue being that the government can say, we don't like this domain name, it's gone. So it was an attempt at a decentralized DNS, and they never really got anything that met all their requirements for that, but one of the tools in their toolbox for trying to create that was the end-to-end encrypted and IP authenticated network, which became a thing in itself. And that's why it's called CJDNS, because that's the part they got working, and it works well, and it's eminently useful for all kinds of things.
How does that expand?
Hmm?
How does the CJDNS?
Well, CJ is Caleb, somebody, he's I forget, it's a Caleb. And so his, and then so it's Caleb, his last name starts with a J, DNS.
So he named it after himself.
Yeah, it's named after itself. So, yeah, and also the concept, and of course, as with any invention that stands on the shoulders of giants, the concept of cryptographic address allocation is not new. There is an RFC for cryptographic address allocation, and it's even recommended for the host part as an alternative to the stateless address allocation that's commonly used, which is based on your MAC address. So he just took that and applied it to the entire IP address and dispensed with the geographic routing. Voice over IP applications. If your voice over IP uses IP6, you can make it into a secure voice over IP application. The only drawback is the jitter is high because there's no quality of service or other way of prioritizing certain packets in CJDNS. And so and people can decide to restart their, their node at any time, at which point you've got to find a new route. So there's a significant delay whenever that happens. So that the jitter makes the voice over IP less than, less quality than you would like. But it does give a quick way to give your, make your IP6 secure. As far as the DNS, Namecoin, I'm not going to go into it, but Namecoin is a more successful attempt to provide a decentralized top-level domain registration. And so that's something to look up. And again, to reiterate, even with DNS security, DNS can be compromised by the root servers or by the government. You can't trust DNS. HTTP with a CJDNS IP is secure. Again, once you with a raw IP, you don't need the whole HTTPS infrastructure because the IP is already authenticated over CJDNS. And in fact, you saw when I didn't use HTTPS when I brought up the map from the h.fce00.org. Now, even though DNS can't be trusted, it is convenient, and the convention is as far as integrating CJDNS with the other, with conventional conventional websites, is you add a prefix of h.dot. So if you have a site that's on the regular internet, which would be fc00.org, and you say h.fc00.org, that would be the CJDNS, and the H stands for Hyperborean. Okay, now, again, this is in the subject of integrating the CJDNS, which is like a big amorphous VPN. It's a mesh VPN accessing the regular internet, which CJDNS call ClearNet, and versus CJDNS is called the darknet. And there's built-in tunnel support. So each, and at the end of this, I have a virtual personal server set up that I'm going to go ahead and install and get CJDNS node connected. So we can see all this in action on the terminal. There's no GUI, point and click, except for the Android one has something like that, but I haven't personally seen it. So there's CJD route has built-in tunnel support. You basically, you have client and server. The server specifies the public IPs of the CJDNS node, public keys that you want to assign a ClearNet IP, and then you just list the ClearNet IPs you want to assign, and they are added to the tunnel device. This is easily commercialized. There are already a number of vendors who will be very happy to sell you ClearNet access over CJDNS. And this is handy for people, to get access to the internet typically, because then this is the only networking they have available locally. Like Poland is one place where this is common. In the rural areas of Poland, there's no commercial internet, but they do have this Wi-Fi linked CJDNS mesh. And so now you can securely connect to your ClearNet provider, and they provide your IPs that you would use on ClearNet. You're looking puzzled. Okay. So each public key is assigned one or more IP4 or IP6 addresses. Okay, so this is why I wanted to do the talk. I spent several months getting the package for Fedora approved and available to the public. And it includes for secure, because this is any code that parses packets from the network is not something you want to trust as little as possible. So networking code like CJDNS parses packets from the network, and so this is a prime target for someone to create malicious packets that trip up the parsing and make it do something nasty. So there's lots of sandboxing available. Obviously, it runs as a CJDNS user, so that it has the traditional Unix user ID sandboxing. In addition, it runs a change root to an empty directory, so that it doesn't have access to any files. It also uses the secure comp, which limits which system calls are available. And I also wrote a targeted SE Linux policy, which further limits what it can do to only what it's supposed to be able to do. So the reason we need all that sandboxing is because it's parsing packets from the internet that could be malicious. And you'll see a similar thing with Wireshark. Wireshark has a constant stream of CVEs where malicious packets are able to crash or seize control of Wireshark. CJDNS is a little better in that Wireshark has to deal with a wide variety of formats, whereas CJDNS is looking for a specific format for the packets. So it is in the stable repositories for Red Hat, for EPAL, for EL6 and 7, and for 22, 23, 24, and in Rawhide. And it's currently release 16. Release 13 is in testing, and it has OpenVZ support. I had to do some minor changes to get it to work with OpenVZ. And my VPS is on OpenVZ, so that's the version that I'll be using. So now let's go to the live demo, which are always I did run through it last night, so it should work. But let's come over here and let's pull one of these terminals off. Okay. And we'll go to our virtual personal server. Maybe. There we go. Okay. So first thing we do is install.
Where is your virtual server?
New York City.
It's New York.
That's when the OpenVZ ones, they were $15 a year for a 128 meg virtual server, and this is a $30 a year 256 meg virtual server. So they canceled the 128 meg plan because IP4 addresses are too expensive. Became their major cost was providing the fixed IP4 address. And I told them they ought to just provide IP6 only, but they said not enough of their customers know how to use IP6. So what do you do? So OpenVZ does not support SE Linux, so I'm not installing the SE Linux targeted policy. And I have a CJD route config already done to save us some time. First of all, I got the peer information. Let's see what that looks like. So these are some peer connection information. The first one is a public peer that came from that public peer site. That's one that anyone can look up. The password will probably change in a few months. And the second one is a link to another personal server. Now notice it has a particular, this is for NoVALUG. So people at NoVALUG or that watch the broadcast will know what the password is, or we can just put it on the website. And if the bandwidth, I mean, I have you know, there's a gigabit byte a month or something at the virtual personal server. It's not a big deal. It's only $15 a year, so if it's maxed out, tough. So that's going to be our 2 peers. And so I'm going to move this. Now normally when you start it up, it will create your, when you do it, you would just start it. And it would create the thing. Oh, but I had to turn off SE comp because secure comp is also not supported on OpenVZ. So all these security measures are problematic on OpenVZ. So that's part of why it's so cheap. So let's put that one back in there. We'll get rid of that guy. And okay. 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 I'm not seeing the problem. Yep, that's all fine. Okay, well, let's go through the configuration things. Okay, so now normally you don't want to let anyone see this private key. So that's why this is on a virtual, you know, throwaway server type thing. So this private key is basically anyone that gets that can now spoof your node. And in fact, when we're done with the demo, I'll probably just go through and regenerate this config and get a new private key, because there's no sense even having this public node be spoofed easily. The public key is what's is normally used for routing and everything, and that is hashed to the IP6 address. And notice the IP6 address starts with FC. That's not just a constant that's thrown in there. What it does is when you're generating an IP, you generate them repeatedly until you get one that starts with FC. Because the vision of CJ is to dispense, his vision is for the entire internet to be based on cryptographic addressing. And so there would be no geographic routing at all. And next, these are passwords for people that are logging into your node. The config file is JSON format. So these are passwords for people logging into your node. They're random. You know, you want to make them random and reasonably long. The config file generator puts in, very conveniently, puts in a selection of random passwords, and as well as your random node IP, etc. And gives you an example of your peer information that you would give to a peer that was going to connect to you. It's the admin interface. This is where I put in the peer information for the public node. And this is the peer information for, this is an IP6 to the Atlanta node. This is where you can disable, if you want, the broadcast beacons on Ethernet for the zero config peers. And this is for connecting to a specific Ethernet IP. IP tunnel is where we discussed assigning ClearNet IPs to a particular, public keys for the CJDNS network. So this is, if you only had CJDNS, this is how you would use another node to route you to the ClearNet. And for the other way, you just list this public IP, go and create a tunnel and use whatever IPs they give you for that tunnel. And if we have time, I'm going to go ahead and activate that to the Atlanta node. Just for fun. And then these are the various security measures. So I'll bet you I know what the problem is. Aha. libsodium is a dependency, and it was installed the first time I installed it, and it was removed when I uninstalled it to get ready for the demo. But now when I installed it, it did not install libsodium. So there's something weird with DNF. So let's go ahead and install libsodium. Oh, I know. Oh, I know what the problem is. It's my fault. System control of DNS is why I forgot how to use updates testing to get the one that runs in OpenVC.
It actually.
Okay, nothing wrong with DNF. I needed the updates testing version that supports OpenVC. Okay, now we're going. And so now we can see there's the tunnel that it creates for the CJDNS itself. You can see its IP6 address. One of the utilities is peer stats. And so we can see the two peers that we have set up. And so now let's try pinging someplace on Hyperborea. We can ping h.fc00.org. And so it should go out, okay, and it's calculated some routes. It looks like it's pretty slow at the moment. So that performance is not real great. I actually have an idea of my hub that I mentioned that I've limited to 512K might be the issue. And I'll bet you if I restart that and kick everybody off, it will. I wonder if it's trying to go through that. Nope. Okay, so now let's try some other places. We can h.atl. This is one of our peers, so this one should be fairly quick because it's basically showing it's a direct peer. And we can do a trace route and see. Actually, I renamed it so it wouldn't conflict. Let's see how we were getting to this fc00.org. So that's how we get to the fc00.org. It goes through those nodes. And if we want to look up the CJDNS IPs, this utility is only showing us the public keys. There's another utility that will convert for you. So that just does the hash and tells you the IP6 address. And these utilities are Java, are the Node.js, so JavaScript. They kind of they're in the CJDNS tools package that I installed. Now, what are we doing on time?
On a whole hour.
A whole hour left? Okay, so let's, at this point, we've covered all the basics. Let's set up a tunnel. So this one I did not pre-do last night. So there will be some mistakes and everything, and problem solving. And are there any questions before we get to that?
I might have some in the end. I'm waiting
Okay.
for some stuff coming up to the public.
So no questions. So let's decide that this is our node here, and I want to create a. Let's see, what's the best way to demonstrate the tunnel? Oh, let's make this a server first. And yeah, I don't want to display the, I should have made two nodes where I could reveal the private key. I'm just going to make this a connect to. I'm going to go and on my own screen configure the Atlanta VPS to have a server. And like we talked about. And then we'll connect to it. So let's go to the Atlanta one. And so I'm going to take the public key of our New York node. And the public key of the New York node is here. So I'm going to go over here. And put it in. I lost my page buffer here. Try this again. Public key. Here. Got it. And so we're going to give it an IP, I'm going to give it an IP6 address on our network. And see, so in Atlanta, our IP6 subnet is 26.018. We give it an IP6 address. And we'll call this 1234. Will be the IP6 address we give it. So we got a public key, we got an IP6 address, and what's our prefix? 64. And now over here, we can should be able to connect to that public key. So let's go up to the outgoing connections, and let me get the public key from the Atlanta node. And so that should do our thing. And now let's restart. And now if we look at our IF config, we should have, okay, we have an IP6 tunnel 0. And, oh no, that's not it. Where is the tunnel created? Ooh, looks like it didn't start. I might have messed up the config somewhere. Yeah, I messed up the config. And hopefully it gave us a clue. Oh, you must specify admin bind. Yeah, I messed up the config file. Up here. I accidentally deleted the opening brace. Okay. So now we should be able to look at our tunnels. And so there is our tunnel for that. And this should work in, I guess, okay, I guess it might be a little different than OpenVZ. Okay, so I guess I should have set this up and torn it down too last night. normally creates another tunnel with the IP that has been created. Let's see what this guy, who is ransom node, did. Nope, it does not seem to, the tunnel does not seem to have taken place.
Did you mention at some point, you're talking specifically from an IPv6 perspective?
Yeah.
Are you using, is that because you're solely an IPv6, or would this also apply to IPv4?
CJDNS supports IP6 only. I mean, its addresses are IP6 because you need a decently large address space to use cryptographic addressing. For comparison, there is a similar idea called, there's a GNU something. GNU has one with 256-bit addresses. I forget what it's called right off. And so that gives you even better cryptographic addressing. And the only problem is you can't use standard network stacks for applications. Your application has to link in the special GNU network code in order to connect to these 256-bit address nodes. But so 128 bits is enough that the cryptographic addressing works pretty well. We can't create, no one can create a collision at this point. That's basically the size of MD5. So if you could create a collision, define the public key. You could potentially do an exhaustive search to find the public key, and maybe computers will be powerful enough to do that successfully in the next few decades. But for now, the 128 bits is a reasonable size for cryptographic addressing. The 64 bits is actually too small. That was in the RFC, and so they had you a whole system for changing your public keys periodically, so there wouldn't be enough time to brute force the the cryptographic address. But
How do you know you're not using an address that's already being?
Because it's 128 bits, and the chances of it's basically the same chance as two different files having the same MD5 hash.
In the rather corner case that if that does happen, you just generate a new address and try again.
If you found out, so you can obviously you can do an experiment with, and for experimenting, one of the tools available is called Civil Sim, where you configure a whole bunch of nodes and it loads them all into memory, and it runs the actual CJD route code, but with instead of networking, it just is between objects and software objects in memory. And so you can simulate various network situations. So you can simulate, or you can easily simulate having two nodes with the same IP. And basically what happens is you just get confused routing for that particular node. sometimes packets, you can send packets anywhere, and but the packets coming back to you sometimes go to one and sometimes go to the other.
So would you sometimes get packets that are not cryptographically signed properly? And
No, you never. Packets are always cryptographically signed properly.
Okay. Would they come back to you as though they're going to the other guy and therefore have the wrong key signing?
No, the premise of this thought experiment is that you have the same key. You're saying, what if you had two different public keys that happen to hash to the same IP address?
Yes.
Yeah, in that case, one of them would not be signed, and the routing actually goes by public IP and not by the IP address. So the routing, you just would not be able to use the IP address. So depending on which public IP you had associated, so one of those two that would register their public key in this distributed hash table that has a public, that has the, as to what its public key is that got hashed to it. And so depending on which public key you currently had cached, that's the one you would be talking to.
The reason I asked for the IPv4, when I just looked up the GitHub project, and their examples uses IPv4. In the comments, they have IPv6.
What do you mean? Yeah.
Well, this is their initial setup.
Oh, that's for a peer. Okay, that's using the UDP for a connection. Remember, that's just for a peer connection. So there's a number of options for peer connections. One of them is Wi-Fi. Another is Ethernet. You can use UDP. You write another plugin for the CJD route and add your favorite connection method. Although pretty much anything can be used with the UDP peer. For instance, yesterday I ran iodine to set up the DNS tunnel, and then ran CJDNS over that. You just set up a UDP peer over your IP4 tunnel over DNS. So that was interesting, which shows the hopelessness of trying to completely isolate your corporate network, no matter what you do.
Okay, so the IPv6 is for tunneling only. Sorry, this tunnel is IPv6 only.
The CJDNS IPs are IP6 only. The tunnels can be anything, IP4, IP6, the connections, the peer connections. The CJDNS is an IP6 network. Okay. It's basically IP6 with the routing reinvented and IP assignment. The conventional IP6 allocates large chunks of the address space, from the top down. And in fact, CJDNS is using a chunk allocated for private address spaces, which is FC00/7. So CJDNS is using half of that, FC00/8. And so that way you're guaranteed not to conflict with any conventional IP6 addresses, although you may conflict with someone else using FC00 for a private address space. I've noticed that most people are now using FD00 for their private address space. They're kind of sort of an unconscious movement to not conflict with the CJDNS.
Thanks.
Even though it's not official. And the IANA wrote an email saying that they were kind of upset that they didn't come to them to allocate an official address space for DNS. But of course, that's politically that's not going to work because the whole motivation of the guy inventing it is to not deal with official address space assignment people.
But he did.
Yeah, he did. He put it
He looked at
into
the official address assignment and said, I'm going to take the public one.
right or the private one.
Yeah.
For your
The
own
one that's already been
purposes.
set aside for.
Right.
That's not what he's doing, yeah.
So, what else can we look at here? It's on vibrate, but it's still bugging me. Someone's trying to get a hold of me. And let's just just demonstrate that this is a normal IP6 address. Assuming, let's make sure we're still on.
Yeah.
Yeah, okay, so we're still on, and so we do, that's what you would get on if you wanted to chat with, so you use that in your IRC. For instance, there's a lot of shortcuts you can take by using the CJDNS IPs. Again, the raw IP, not because the DNS isn't as trusted. For instance, I use ZNC, which is also in Fedora, which keeps you logged on to a bunch of IRC channels, and then maintains history while your laptop's doing other stuff, and then you can come back to it. And so your connection to that, you don't need SSL and all that. You just use the raw CJDNS IP. All the CJDNS IRC chats are on CJDNS. So everyone has an authenticated IP. And the servers, IRC servers, have an authenticated IP. So you're talking to the right server. There's no need for SSL, no need for...
Well, you're doing what SSL does.
Right, you're doing what SSL does, but at the IP level. So, and that's important to keep in mind because it's so tempting to say, gee, I'd secure if I just connect to Gathman.org, but no, it's not, because DNS might have been compromised and it might resolve to a completely different IP.
Yeah, but that's what SSL will capture, right?
Well, SSL verifies the domain name, and the IP can vary.
So if you're assuming the site was duplicated 100%, you're right? You need the private key. But that's the only assumptions you have. If I get the same private IP, so your private key from your IP, I can spoof that too.
Right, the CJDNS private key.
Right, and you're assuming that you're compromising SSL when you have the SSL private key. So I'm just equating both situations. Right. I can break both.
Right, but SSL verifies the domain name, that it matches the certificate.
Yeah, but it only matches if you have the private key.
Right.
So
I'm assuming
you have to use the private key to have it.
Right. I'm assuming the private keys are secure in this discussion. So SSL verifies the domain.
So you can't create a site duplicates unless you have a private key with SSL, even though you duplicate.
But it lets the IP vary. So the point of SSL is you can have a server farm with all different IPs, and they all have access to the same private
because
key.
I don't care how it's implemented. I just care about the site response.
Right. So when you're connecting with CJDNS, you can connect to the IP, and that's authenticated just as securely as SSL.
Right. But I don't see it at any better level. I see it just different.
Yeah, it's different. But it doesn't. But the domain is not authenticated. Now you can run both.
So I guess my follow-up question on this is that this isn't actually registering any of the H prefix DNS stuff for you. You actually went and did that.
Oh, the H dot? Yes, I had
Okay,
pre-done
so
that.
this is the public DNS that's actually saying. that it
Right,
would be
that's the public
internal.
DNS, and it could decide to
So,
lie to us at
Yeah,
any time.
that's completely up to what you put there.
Right, and that's why it's .gathman.org. Okay, now, some other things in the culture. One thing they are looking for is, how do you identify, is the equivalent of reverse DNS. So obviously reverse DNS works, and it can actually be secure if you just query the IP itself, because you know, it's authenticated. So you know you were getting the right answer if you do the RDNS query on the node itself. But it's no one has written a mini, DNS server that you ought to be able to do a mini one that with no configuration that just serves RDNS for this CJDNS node, and that's it. Or even any kind of RDNS for this.
But if I go
node.
to the trouble of asking the node what its reverse IP should be to the authenticated IP, it'll come back to the name?
Yes.
Okay.
So that's one way of doing it is reverse DNS. But that's not popular in Hyperborea because no one's written that, no brainer, install this and your laptop starts responding to our DNS queries. So obviously I have written, so I have a RDNS server on Hyperborea that knows about IPs that I use. So I can say host, this, not that guy, what's one that I use? Okay, here's one that would probably be in there. So you want this guy, and let's ask, actually, I'm not authorized, so it's not going to let me ask, but we'll see what happens. Oh, it does let me ask. How about that? Okay. So you ask my server on Hyperborea, and it will tell you what the domain name is. And once you get the name, you can verify it. So that works. Now, another thing that people do is a node info. There are simple HTTP servers that are easy to install and set up. So with node info, you would go to, let's see, we have wget on here. Yes, okay, so if we wget dash standard out and h dot, let's just do this one. It's not gonna let me. And who would be have one set up? Okay, no, okay, that's good. That one's not set up. Just a second, let me start that on here. This is a, okay. Okay, so it, and what we want is, node info.json. So this is what a lot of nodes on Hyperborea are doing. You just have a JSON file at nodeinfo.json. And so obviously you can have extra keys and that are ignored, and it's kind of an evolving standard. So you can put contact information and stuff. And whatever you want to tell the world about you, and so that's the other standard that's coming up for identifying what an IP is. The that map, there's the map, it seems to think it has a GitHub page where somebody set up a GitHub page where you can go in and add your CJDNS IPs as a pull request. So that's kind of the host file 2.0. So that obviously isn't very scalable. Now, there have been talks, there's lots of, since we have time, there's the Namecoin is what I think is the most promising decentralized DNS solution. Is people here familiar with Namecoin? Okay, it's, you've heard of Bitcoin. It uses the blockchain. So it's the same idea as Bitcoin, but you can one of the transactions defined is to turn your name coins into a domain name. And so then the domain name is basically first come, first serve. And it has a price so that to discourage I mean, you still have squatters because Namecoin was really cheap when it first started, and so people ran out and bought up all kinds of names they thought they'd be able to sell later. And but now that the Namecoin, you know, does cost a little bit of money, it discourages people just buying names for no reason. And but once you've got the name, then you can't, you know, there's no central authority that can take it away. Now that also means that there's no trademark disputes. You know, I guess there could be, you could, you know, someone took your trademark name on Namecoin, you'd take them to court and the court would say, you bad boy, you transfer that name to this trademark owner now, or you're going to get it. And that would probably be one way to approach it. Or there could just be both. You know, you have the centralized DNS where there's a technical.
How can you charge without having some kind of control?
The way Bitcoin works.
So you have a type of control. So if you have a court order that says you have to revoke whatever things you've done, to give it to someone else, that isn't enforceable. That is something that can be done technically. It's not like you can say there's no one that can.
But the person would have to either do it voluntarily, or you would have to raid their, you know, place and find their private key. Presumably, the person would do it. The rational thing to do would be to do it voluntarily, unless there was some huge political issue involved or something. But with the IANA internet, if the court just tells the registrar, hey, this domain really belongs to this guy, go ahead and, you know, change it.
Well, the problem with jurisdiction is that multiple of them. Right? You may have, and that's the battle we have today. The one court in Europe is trying to tell companies in the U.S. what to do and vice versa, and it's not working very well. So,
as far as the underlying technical aspect, Namecoin is first come, first serve. And so there's no technical way for the, you know, for some centralized authority to just do it. Whoever owns the name owns it, and you know, if there's a trademark dispute or something like that, you know, they've got to turn it over. The owner of the private key has to turn it over. And the names do expire. So let's say, if there's someone that spitefully says, well, gee, registered McDonald's and they won't pay my, $20 million to give it to them, even though they've got it trademarked. So I'm just going to destroy my private key and no one can have it. And but that doesn't work either because the name just expires after, I think it's 36,000 blocks. And at that point, McDonald's would take it. Assuming, but at this point, no corporations have much interest in .bit domains because not enough people know how to resolve them.
Well, you saw all the new subdomains coming out and how little success they had. All the new subdomains that came out in normal DNS, and most businesses were not interested, right?
Right.
So it's, I think, they realized they could keep on going down that game, right? If they want to have every top domain with their name on it, it's not only expensive, but why?
Uh-huh.
I think this might be one of those. It doesn't really matter to them. But I also think you're going to find there are some interests that basically will say, hey, I paid a lot of money to have this name recognized, and having someone else abuse that or taken hostage, and that's what we got legal systems to help prevent.
Right.
And a system that would be built up around the concept of allowing that to happen without recourse might be a problem.
Right. I mean, there is recourse. Just it's.
But you can't enforce it.
Well,
if the guy blows up his computer and there's no key.
If nothing else, you put the guy in prison until the name expires.
But the name is still out there, and if you have something on the site that resolves with some stupid stuff that you don't want to associate with your site.
Without the private key, I mean, if he has any automatic systems, you can shut them down until the name expires.
So you're saying that as long as you have access to the server farm, so we are back to the problem we have today, that a U.S. court can enforce edicts on non-U.S.
No, suppose you're this guy who has the McDonald's name under his private name coin key, and McDonald's is upset with that, and he won't give it to him for some irrational reason. Maybe he's loony in the head. And McDonald's probably even offered him a couple $1,000s for it. But he's not satisfied with that. So, so the court orders him to turn it over. So if he has to actively renew that domain every 36,000 blocks, which costs Namecoin. So someone's got to, and which private key has, has the Namecoin. So, has that name registered. So you can see whether any money is being transferred to that private key, and you can see whether that domain is being renewed. It's on the public blockchain. So whether he's complying with the order. And if he doesn't comply with the order, you can start restricting liberties. So, if he personally has to press a key in order to renew the domain, then putting him in jail.
You may not have to just set it up on a server in China, and
right.
What are you going to do?
You mean he has someone in China that's doing it for him that has
access? They have a dumb little jump job that will do it automatically. Every 1 week, whatever, runs the script to
the money's got to come from someplace.
Yeah, you have an account somewhere, a Bitcoin account.
Right, a Namecoin account, right? So he's just got all kinds of money stored up in Namecoin to keep that name registered for a long time.
Could be. Maybe he had $10,000 on it. It can roll last for a while, probably.
Okay. Well, in that case, he has succeeded in his revenge against the McDonald's corporation.
So you have a system that allows the bad guys, without recourse, right? And that's the system we're fighting today. Is that there's no global authority that can enforce it. All you need to do is go between two jurisdictions, and you can play them out against each other forever about anything. Right? And that's the problem with the global economy and global systems that we have now.
Well, anyway, at this point, I'm not sure McDonald's would even care.
Well, if it's
if the guy cares that much to have the domain registered under .bit, to sit in jail and have
as long as it's not, and if the end users don't care about the domains, and that's what happened with all these subdomains, then you're right. But the moment you have a subdomain that might be successful, My point is that wouldn't be successful, it wouldn't be useful.
Right. So
Because
that's
why would I adopt a system that is even worse than what I have today?
Well, that's why I suggested that you need both. So that McDonald's, companies that are, to whom trademarks are very important, would use the top-down system, where the court orders are more easily enforced, and the name coin system would be more for private individuals that don't like the censorship that comes along with
Sure.
that.
So I make a site saying something about you in person, right? And I put all kinds of lies and stupid doctor pictures on there and whatever. And you have no recourse against me. I'm not a corporation. You're not a corporation. I just made a dumb website. And I published that. Yeah, it has your name on it. Has all kinds of lies and BS and all that stuff, right? I mean, standard slander stuff. And I can't, in that site, you can't get down.
That's right.
And that's my problem with the level of anonymity, is that I fully get, I don't trust the government. I get that part of it. But I need a government to enforce some of my rights. So I need them to a certain level. I don't like the overreach we have. But without it, I think I have a worse system than I have today.
Well, you can have your real page on
but what's going to be the difference if you want two worlds that you said these are all privately run, non-corporation stuff, and I can put stuff out there that I can, that no one else can touch.
Right.
Even if I break the law or whatever. Maybe, let's say I put a recipe on there how to make an overdose and do shit. I mean, stuff like that people are real stupid people really are doing, right? And you have no court resource against getting rid of that.
Right. Well, you're not going to have, there's always going to be that. You're not going to have, there's always going to be ways for people to put information out there.
And there's always ways also to get rid of it, particularly if it's hosted within, again, your jurisdiction. And that's the only problem we have left, is that this international collaboration is not really working because some countries just don't care. They're not at that level, and some care so much that they want to restrict all traffic. Right?
Yeah, well, so there was a thing on Facebook where someone had a Facebook page, and then they had the real. I forget who the celebrity was. The Facebook page celebrity. So then the celebrity says the real celebrity, and so immediately, at a minimum, as someone looking at those pages, one of them's a fake.
It's like the Bible, right? There's so many of them.
So I don't see so I think with corporations having the government resource, that's good. But with the private page, I don't see a problem, as soon as there is, two of them claiming to be the same person.
And I have recourse, I can do something. Now, it is a lot of time. I get that's part of the problem, right? But if it is run by a server that is within the jurisdictions that I can access. I mean, we do, at least if it's in Europe and the US, probably most of South America, I can do something. It's just going to take a while. It's Asia that's today's problem, right? It's that we can't really enforce our things. And vice versa. They're running stuff here that the Chinese government can't touch. It goes both ways. And most Americans look at that, oh, that's a good idea, one way, but the other way is not good, right?
Oh, I think it's good both ways.
Yeah. But it's part of the problem you have is that you're arguing on one end, I don't want to be able to have an enforcement against me because I don't really want to have people recognize I'm in control of this. I want the information to be free, or whatever we said way before the internet became big. But on the other hand, if it's that free, that means this information is free too.
Yeah.
Right. And
so that's why I said there's room for both. So with the .com domain, that the courts are, have a say over trademarks and all that stuff.
In
with
the US,
.bit
to a
domain,
degree,
you don't.
yes, but not if I was outside. Yep.
Right. So And just you might be interested. The guy that did worked CJDNS, you know, the DNS project, and never came up with something satisfactory, and he was wrestling with these same issues. And at one point, he said on IRC, we need a you know blankety blankety blank government.
Yeah.
So he was wrestling with some of the same issues as to how to you know, have some way for people to you know, express political opinions without getting censored, but yet without having this libel and trademark violations and this kind of stuff.
I mean, it's funny. I see a lot of the people battling the government side changing their mind the moment they are the, you know, the target of those kind of.
Yeah.
It's like it's fun when it happens to others, but not to me. Like,
Right. Yeah, well, so the recourse with that situation where someone puts a defamatory page in your name on the .bit domain is you put up the real page, and that at least.
And then I'll put up the real page, right? I mean, I can be the
Right.
teenager again, argue that.
Well, then people know there's a controversy.
Well, there's always going to be a controversy. I mean, even if I only have one page, that doesn't mean that that's correct.
Well, let's put it this way. People are always going to be able to tell lies about you. And the government can only do so much to stop that. And sometimes the government tells
people
lies
can
about
always
you.
kill people too, right?
So I
You
don't
can't
think
stop
there is a
everyone.
solution.
But you have a process around, well, having
So-
a solution doesn't mean that it can't be done. Having a solution means if someone does it, there's a recourse.
So anyway, this is why CJ kind of gave up on the DNS aspect and concentrated on the networking aspect, because he couldn't come to a satisfactory solution quickly on the DNS
But
aspect.
you've got to have to be authorized at some point, right? You've got to be able to say, well, this name resolves to that, and not just take the first answer you're getting, because then it's very easy for anyone in your chain to tell you something that is not true. And remember, we start without DNS, we start with host files. And the reason host files doesn't work was just took one misconfiguration of one server, and the crap didn't work anymore, right? I mean, and that was local, full local control. I knew exactly what my server knew and not me. That was easy, right? But that didn't work either. So decentralized control of something that I think by its nature is centralized.
Well, the name coin doesn't have that problem. In a sense, it's centralized, but it's an automatic, you know, it's a mechanism that doesn't have personal control. I mean, there is one and only one definition for any given name, the name coin.
Mhm.
And whichever.
But you're going to have
control
multiple servers because, I mean, if I take my example, if the court can't enforce it because some idiot, you know, sets up that server, I mean, they can pretty much just order the servers down there, meaning the central server down. So if it's not decentralized like Bitcoin is,
well,
then it's just a vulnerable, right?
It is decentralized like Bitcoin.
Okay, I thought you said it was. Oh, sorry.
I mean, there's one and only one version, just like there's only, you know, it's a shared ledger.
Okay.
So, yeah, the name registrations are a transaction, just like a Bitcoin transfer.
Okay, so yeah, I may not at any point in time have the full truth, but I have a way of determining what the full truth is in the network.
Right. And you can still have forks. That's another issue.
Mhm.
What happens if there's an EMP attack on the US and it's isolated from the rest of the world for 6 months, and meanwhile we continue doing Bitcoin and Namecoin transactions, and then we reconnect, and now there's 2 different ledgers from that point.
Oh, it's split brain. Good old split brain.
So that's what can happen to Bitcoin and Namecoin.
Mhm.
And basically at that point, what would happen in practice with the current software is each block would basically get voted on by who had the most confirmations. And so it could be either way. And when there were no conflicts, there wouldn't be a problem.
Yeah, humans.
But where there was a conflict, it would basically be a vote on which miners have the most confirmations.
So I compared CJDNS while you were talking to some other ones, and one of the arguments against it, and that's why I was waiting for you to talk about it, was that CJDNS is not anonymous in a sense. You can actually trace back where the originator is.
That's right.
And that was one of the arguments against it.
Well, that's one of the things it doesn't do. Anonymity is a layer you can add on top, but anonymity always is going to suck performance. Because you've got to add all these random redirections all over the place. So for decent performance, you've got to forget about anonymity. So what CJDNS does is it basically gives you an IP address that is not location dependent and doesn't require any, and for apart from the government arguments for your private VPN, and it's a huge pain to have to organize how, IP allocations just within your own organization. And so using the cryptographic allocation relieves you of that chore. The IPs are all random, and it's just, and your organization is basically then listing which ones are authorized for, various things, which can also be an issue, but it's at least you don't have the issue.
That's the counter of the whole idea, I think, what the network became, what the internet became, was that you really didn't care. I wouldn't say, you said early on that the routing was centralized. I wouldn't necessarily agree with that 100%. But we have a very big backbone that without it, we will probably notice it very quickly.
Right. But you can set up personal point-to-point links, and I have open VPN links between.
But the idea of the network was, at any point in the network, you don't care how you get to the other point of the network. And that was the part of the TCP or the IP network in the beginning, right?
Right.
And that's still there. I may take 2 different travels through the network at any point in time, depending on what the routers think is necessary.
Right.
But I still need, but the whole idea is that I don't need a central authority to tell me what's around me. I can discover that and connect to anything. What you're sort of saying is you want to whitelist every endpoint that you want to connect to, and have like a pre-agreement that says, well, if I want to talk to you, here's the encryption that we agree on between us. So my big question would be, how do I discover new services then?
I mean, no. Once it's just like any other IP address. There's no pre-agreement or anything.
So when I looked at the tunnels, it looks like I need to have a private public key agreement between the endpoint in order to sign it.
No, that's only used. The public keys are only used to validate the IP, to authenticate the IP. So you know that that IP is not being spoofed. The public key will hash to the IP.
I was looking at this as a tunnel and saying, okay, so maybe I misunderstood that. So this is just a way of saying any IP out there responding, I can validate that you are who you are.
Right, and it's end-to-end encrypted.
So you have a database of all the public keys then.
Right, the distributed hash table. Although that's not.
That to me seems like it would be in a configuration file. That's what I'm talking about. Is a pre-agreement. Is it not in a configuration file?
No, that's just your immediate peers. Remember when we compared the different configuration strategies? Where's the?
So how does that differentiate from Tor?
Well, Tor is horrible performance that gives you anonymity.
No, not really, because I go to an end node and then that routes out to the normal network. I just don't necessarily care what end node it is, but.
And so with CJDNS, it's immediate peer configuration only. And you don't really need the distributed hash table because you can ask your immediate peers, who are your peers? And then you can ask, one of those, well, who are your peers? And eventually discover the node you're trying to get to. The distributed hash table is just a shortcut to more quickly be able to find a path to the public key.
How does that not become so chatty that it dies within a certain size?
That's why you use the distributed hash table, so that you can directly get some information about a public key. Without going through and asking.
Well, so I mean, the current routing, when I'm looking IPv6 and IPv4, you look at part of the address, and you have a router, right? But then you know that this area address is hosted. If I need to send you something here, I need to send it that way. If I don't know it, I send it up higher until someone knows.
Yeah, that's geographic routing. That's the way the regular internet works.
Yeah. But that's the way the route tables work, right? So they are, but when I go on the
That's not
backbones,
how-
it's still like a humongous route table, right?
Right.
But if I don't know, if I can't determine an easier route by just looking at the address, it's kind of like when I look at my zip code. At least I know, oh, I need to go to that city
Right,
first,
that's
and then I need to find
Right.
the
That's
district.
geographic routing.
But if I don't have that, and any endpoint can be within reach, and I have to build that network of all the connectivity in order for me to get from point A to Z, here's the route, a potential route that I have.
Right. So now you see why it has the distributed hash table. Because first of all, with the source routing, that abstracts the issue away from the protocol. Each sending node waves a magic wand and comes up with a path to the destination.
Right.
Okay, and then the actual protocol you just
But
say.
that's one heck of a calculation every time. You have a ton of.
Right. Well, there's a number of ways to solve that problem, and a number of them, and we're on like several iterations into it. And so this is understanding. This is where the super nodes come in. That's another iteration. And I have my own theory, which when I get some time, I'm going to implement. Which I think will work really great. But that's the beauty of source routing, is that you can experiment with these different algorithms and find out which one really does work great.
But how many addresses do we have in the IPv6 space, or even just in the address space, the CJDNS?
But in Hyperborea, you've got maybe 5,000
addresses. That's
Yeah.
all IPs.
Yeah,
I thought that
that are
private network was much bigger than that.
It's active nodes, not space.
Okay, and how big is the address space?
128 bits.
So that's a couple trillions at least. All right. And I'm just imagining the calculations for me to figure out the potential routes, which if, let's say just half of those would take. Right? We look at today an IP space that are completely taken out, but I don't think we're going to get there.
Well,
like
first of all, let me tell you one concept that's used by all these non-geographic routing systems. It's called, they have a way of determining which IP is nearest to you without any reference to physical location. You simply take the hash address and you see how close it is numerically. It's arbitrary and somewhat random, but
if it's random, how do you get any information out of the hash?
It's a defined order. And once you have a defined order, you can have an efficient search algorithm.
I get that I can optimize my binary search and my search in memory for an address to see where I might have.
And you can also avoid loops. Like when you, let's say that you don't want to bother finding an optimal route, so you just want to ask this node, in fact, that's what this super node solution is about. Because some nodes are not going to have the memory where they want to.
Well, that's one thing. This is
but they want to completely.
Ahead.
Well, currently CJDNS uses at most 8 megs, so which is fairly small. and
From a kernel
runs.
space perspective, it's big, but yeah, it's small.
That's small, okay? So it fits on little embedded routers just fine. And that's at the most when you've got thousands of nodes that you're dealing with.
But with a super, if you have a node that needs that much compute and memory power to do it, what's the difference between that and the backbone system we have now, where we are so depending on third-party systems to make?
The difference is this all still being recorded?
Let me ask one question
Want me
here.
to turn it off? I can turn it off.
No, that's fine.
That's good.
I'm just hoping
Do you
people.
know who's in charge of this meetup?
This guy. Oh, that guy.
It's right behind you.
Okay, that was a good question. It was, but I forgot what it was.
The reliance on supernodes.
Yeah.
The difference is there's more than one supernode. You have a choice. If you decide you don't trust a particular supernode, you can configure your smartphone to not use it. And so it's a
Well,
choice
that's,
thing.
I think that's a.
I'm not
It's not a
saying.
real true choice, right? Because I may not trust them on some level, but not on others.
Right. Well, in
and
this case,
expecting
you're only trusting them to give you a route that works.
Right. But that's what I do with the backbone too. Right. With the IP backbone that we have for IP6 and
Well, no, it's different because with the backbone, they can actually cut you off.
Why wouldn't the supernode be able to do that too?
Well, they could give you a route that doesn't work, at which point you stop using them.
Why?
But with the backbone, if they cut you off, you don't have any recourse.
Well, not everything goes to the same backbone.
I mean, your recourse is to set up your own personal point-to-point link.
Right, well, that's what people
someone
do.
else.
They start a VPN to an address and route through that.
Right.
There are ways around, and that's, again, go back to China, that's how they get our firewall used to.
Right.
I haven't followed up since they closed the VPN options. But
Right. So you're correct. There are ways to around that problem with the internet backbone, and so. But the more immediate problem is with the IP address allocation. At this point, they could say, well, your IP address now belongs to so-and-so. And all the, normal routing tables will go to so-and-so. And sure, you can set up your own private point-to-point links that take it to your place instead. But you're basically just shadowing what's now the official destination of that IP address.
But that's, again, part of the network magic that we have. Right?
So that's why your
dependencies
IP address can be censored by the central organization.
Sure, but we're still having, if you have those compute nodes, if they need to be that big, I don't know if you're going to avoid having that central place that can afford that, right? Just like we have huge data centers that just do DNS, which always strikes me like weird. But we do, right, for root service. Anyway, I like the topic because it's.
So anyway, with the crypto address allocation, there's no need for a central address authority.
Well, the moment you get into talking about supernodes and all that, I mean, that's literally what you're doing.
That just reduces the memory requirements for some of the nodes in the CJDNS network.
Yes, but I'm taking my load, and most people don't know that route anyway, right? I'm taking my load and outsourcing it, whatever, to something else that can deal with it, right? And then that's sort of what I do. I mean, I could technically.
Right, and a lot of people don't like the supernode concept.
Yeah.
But remember that it's source routed, so you don't have to use the supernode algorithm. You can say, I like the old way with the distributed hash table.
As long as the network is fairly small, I think that's possible.
Right.
And that's the problem I see with this thing is that going forward, if it became popular.
Well, that's why they're continuing to work on the routing algorithms.
But I still think with the level of overhead you have per endpoint, that's a big threshold to get over, right?
So what the supernodes do is, yeah, you're right. It lets you make some nodes smaller memory requirements at the expense of moving some of the routing discovery to a supernode.
But could you imagine getting a Linksys level compute power to to route to a fairly large network this way. I mean, that's what in my head I go, I need, maybe
Well,
this is
first
just
of
not
all,
an
you
issue.
don't need the entire routing table in your node. You just need, that's why it's a distributed hash table.
But I need to know where my uplinks are and
No,
where the right uplink is for this
no, you only
package.
have your immediate peers. That's just
Right, but
like-
which of those peers, so any of those peers work for
yeah,
any package?
yeah.
So I need to trust my peers now. So this is what I'm
I
struggling
mean,
with.
all your
you're
peers,
doing
all
is,
your peers can do is, I mean, they can't read your packets or anything. All they can do
but they
is
can control
refuse
it, they
to-
can block me.
They can block you, at which point you got to use a different peer. I mean, it
So
looks
it
no
needs to be on the
different
same
than-
network,
than,
right?
You know, if your peer was my laptop and I close the lid, suddenly you're blocked.
Right, and so to me, that's, forget the OS, that's a VPN connection, right? So that's like a VPN. I have a VPN peer that is encrypted to my endpoint, even though you can't read my packages on the end. It doesn't get
Well,
monitored.
the problem with a VPN endpoint is they can read your packets.
Because it's that's what I'm saying, but that's like the Tor nodes, right? That you send you have different levels of encryption as you go through.
Right.
I don't know if you're doing that, but I still have to have a trust to those peers.
Only
Right, so
that
all
they're
you're
not-
doing is if you're not
only
doing-
in Tor, what you're concerned about, you don't need to trust them as far as decrypting your message.
Well, they're
What you're
known
concerned
level.
about is revealing to some authority which IP the message came from.
True. That's still because you're encrypting on the package level, but
And I understand the NSA has quite a few Tor nodes.
oh yeah, of
So
course they do.
I'm not sure how anonymous it really
I'm
makes
just,
you.
to me, I don't see a much bigger difference between having peers and having have multiple default gateways. Because I don't know how my peers are dealing with it. I don't know how they can be trusted. And some
Well,
level,
you
someone
don't
needs to
have
be
to
able
trust
to.
them to do anything except
But,
relay your
but at
packets.
some point, you got to look at the destination to get it there, right? Because if that peer just sends it on to his peer, to say, my packets are never going to get there.
No, it's source routed. You tell them which peer to send it to next. You give them the entire route.
So you got to look up that route. So again, so now I need so I'm back to the initial point. If I need to calculate the full route, and which is what I read,
You don't need to know the full network. That's why you have.
No, but I need to say, in order to get from my IP to that IP, you just told me I have to tell each of them what endpoints they need to go to.
That's correct.
So I need to figure out what that route is. That's a route to me.
Yeah,
So I need to look that up on my little device.
right, which actually doesn't take that much memory because it uses a distributed hash table.
As long as you have a very small address. But
No,
that-
it doesn't matter, okay? That's the part you're missing. You don't need to know the whole network. The reason for the super nodes, which knowing about more of the network is not because routing doesn't work with even billions of nodes with the distributed
So that's
hash
just like,
table.
okay, so you're not sending the
It's because they want to
packet.
get better routes.
Right, but so
Finding
Yes.
a route is perfectly practical with a huge number of nodes using the distributed hash
let
table.
me rephrase. I'm not sending my packets for you to send it on. I'm sending a request out to get that route list from someone else. So I understand that I'm not, today, I'm sending you the data, you send it on because you know the destination. The world you're talking about is, I get that route from a calculation that is done,
supernode, right.
from a supernode.
Which
So,
will presumably know about more of the network and can find a more
Bingo.
optimal
but that's
route.
the same dependency I have on my routers today. That's what I'm trying to say.
That's right, but you don't have to depend on the supernode. You could just continue doing the routing the way you do it now.
So, and that means I need to
You
know
have
that
a
whole
less
thing.
optimal route.
And then I need to still do that calculation, right? So if I
Right.
want to have a small device, I need to have that dependency. If I
It
want to have a
actually
big
still runs
supercomputer,
very well on a small device.
as long as it's a small hash table.
No, the hash table is distributed. It can
And
be
then
any
we keep going in
size.
circle. If you're saying I have the choice of not doing that distributed, because I don't trust the
No, you're
supernodes.
confusing. The distributed hash table is the way it works now. The future thing is with the supernode does not use the distributed hash table. It uses a supernode instead.
So that way you can fall back to say, well, just give me my next hop.
Okay, so I'm not sending my package out. I'm sending it to my peers. I need to know how to get to point A. So I'm sending that out to one of my peers from a distributed query. It doesn't know it, it sends it on, it sends it on, it sends it on, until I get a reply, because I don't know where that answer is, correct?
No, you always know how to get to some nodes, and they will have parts of the distributed
Right.
hash table so that you can, right, so.
So they have parts, but what parts do they have? The one I have, they don't,
Very
they send it
quickly,
out.
with only a few branches, okay, can get to any node in the distributed hash table. Modulo the
So how
Sybil
do it,
attack
does it
we
know where
talked
to send
about.
it? If I'm sending it to a random peer, to say, I don't know how to get to point B, and that random peer has a set of known peers. The only thing it knows is, don't ask me, because I did.
Don't think of it as asking a peer. You've got the distributed hash table is an algorithm where any node can register information about itself,
Right.
routing information, in this publicly addressable table that you index by the IP address.
So we're,
It's a big
So,
hash table that you
I
can look
get that,
up
but you're confusing
efficiently.
implementation with data. If I'm gonna have a hash table, I don't care if all IPs routable possible, it's
Right.
big, and
Right.
it's gonna be bulky, and it's gonna be compute power. If it's a small
No,
table, it's
this is
okay.
a distributed hash table, and so
Because it has multiple copies that are fragmented around. And I'm
That's
saying,
right.
How do you know which
not
fragment to
copies,
query?
pieces.
Yeah, but the fragments may also exist in multiple, but how do I get to the right place that has the right fragment? How do I know where that goes? So if
I mean, that's part of the distributed hash table algorithm. As part of, you only need to query one node, and then you get pointers to the next one.
It's a logarithmic equation that is
Okay.
used a lot in object stores.
Mhm.
So object stores do the same thing.
Yeah.
So basically it goes in once, and then so up to, it's like 1 million records will have no more than 3 long. Hops.
Right, but that's because it has the address. It looks just what our routing says. If it's in with this space, I need to go over there. If it's in this space, that's what this is not doing.
No, I think
That's what it is doing.
He's saying it is doing.
That's how it works currently.
So it's not a random address.
It's not a what? It's random access, a distributed hash. Just conceptually, it's a big hash table that you can very quickly look up any entry.
So I know anything within this IP range is over there, and everything within, or at least that one will know where to go if I send it over to him.
And as far as, since it's not geographically routed, over there means a numerical comparison of the IP. So that's how you can avoid loops and quickly find a path.
Well, I mean, I get the opera model, right? As long as I say that I can split my space into smaller pieces,
right?
And that piece might be split into all smaller pieces and go out any depth, and you can mathematically control that. That I get, but I thought that was the whole point. We didn't have that central idea of who owned what address space.
Well, it's not central.
It's not centralized, it's just split up. So it's trading off for your peers. You're going to get 2 pieces of information. That you're going to get a chunk of your hash table that's actually local to you.
Yep.
You're going to get the list of the peers that are closest to you. If I walk for something,
and that's going to have pointers to additional things.
It points to an additional hash table that you can ask any of the other peers.
Okay.
Which they will in turn then be able to try and dereference. So it's trading in the latency of the lookup because you don't have the entire list of everything else.
But you can cache it.
Right.
And that's that's basically what the 8 megs is used for, is caching enough of it to get good performance for the number of destinations that you'd be talking to.
Now again, once you have the IP, you can keep that, although that opens up another one. But that's okay.
Now, if you want to hear about my idea for better routing for CJDNS, it's this requires a larger memory node, or it could be something used in a super node for and it's called electric routing. And the idea is you need a fairly large hunk of the network mapped out, and a measure of the resistance, of the difficulty of traversing each link, which is an analog of resistance, and then you apply the electric walk algorithm when you compute the amount of current that goes through a wire. when you have a voltage at one end. So if your source and your destination IPs are like two nodes and a resistor network, and your links are the resistors, then what is the voltage drop across each resistor? And at that point, the probability of taking the peer is proportional to the voltage of that peer for the destination you want to go to. So each packet takes a random route. Just like electrons, they essentially make a quantum decision as to which branch they're going to take in the resistor network. And it's random, but the total number of electrons is proportional to the voltage. And so that way, that optimizes. There's a nice paper, I don't have the name with me at the moment, showing that that is a mathematically optimal utilization of network resources and for the mesh. And it's a reasonable amount of calculation if you have enough memory to store, you know, enough of those graph nodes. And once you do the graph, once you do the electric walk calculation to get the voltage, you basically, all you need to store in your cache is the peer voltage by destination. So it's a reasonable amount of data that you have to cache after you do that calculation. So you could even combine it, have some protocol with a supernode where the supernode could like have a big graph, pre-calculate the voltages and just download voltage information to you. And then the peer could actually do, you know, the small node could actually do the randomized choice of which branch it's going to take for any given packet.
All right. Well, let's go ahead and, yeah, go ahead and stop.